Semiconductors can also be classified as elemental semiconductors and compound semiconductors. Elemental semiconductors are also known as simple semiconductors. Elemental semiconductors like germanium and silicon consist of only one element, whereas compound semiconductors consist of more than one element. For example, gallium arsenide and gallium phosphide. Actually, you may see that the classification of semiconductors into intrinsic and extrinsic semiconductor is sometimes called as classification on the basis of doping. But doping itself is a process which changes composition of intrinsic semiconductor. It is just a matter of opinion. Let me give you an example. Some authors who write books for higher studies have divided semiconductors into three categories: intrinsic, extrinsic, and pure. They consider pure semiconductor and intrinsic semiconductor to be different, but they have a valid point to put on the table. They say that a pure semiconductor must have a regular arrangement of atoms with no defects up to infinity, but obviously it is not possible. A normal semiconductor will have some definite shape and boundary, and at the boundary, the regular arrangement condition will not be valid. Since there cannot be a semiconductor with no possible boundary, it simply means it is hypothetical, or you say it cannot exist. But since it is not practically available to us to study and for establishing relation between different parameters, we assume that the relations and formulas which we derive for intrinsic semiconductors are valid for pure semiconductors as well. Another example we have is of energy band gap. You have studied the relationship between the energy band gap and the temperature. However, at a particular temperature, this particular formula will give you only a single value. However, you have also studied that there is a band of energy levels in which electrons are present in different bands. Therefore, it is not possible that all the electrons present in a crystal will require exactly the same amount of energy for making transition. Obviously, this is true, but it is also not practical to find different value of energy that are required by different electrons for excitation. Therefore, in general, we assume that electron on average will require energy equal to energy band gap for making transition. It is not like who is wrong or who is right. It is just a matter of opinion of different authors. Some authors will try to simplify things so that graduate level students don't feel the subject hard and will enjoy learning. But some authors think that it is better to bring the students into the real world phenomena even if it becomes quite complex. No one is right and no one is wrong. It is just a matter of different opinion. Also, it is not ethical for me or for anybody to simply open a book and read it line by line. By doing so, you are disrespecting the author's hard work. I always ask you to prefer reading books, even if I have to select one from my lectures and books. I would definitely ask you to go for books. Read at least two books from different authors. You need not to solve questions as it will take too much time. By reading books from different authors, you will get much broader idea about the subject. And if you have time and wanna strengthen your concepts, then watch videos, or if you find any concept quite difficult or are unclear about the topic, then you should go for video lectures. I personally try to simplify things rather than to make it high standard or complex looking. I will cover almost all mathematical relations and dependence of different parameters with one another. But still, it is not practical for me to read a book. Well, keep reading books and enjoy learning.